Next slide. Good morning, dear students. Last class we discussed about light sources in that about the LED structure, LED operation, and how these LEDs will be useful in the optical communication side. Right? Today we see other light source. As per the syllabus, we have the other light source is lasers or laser diodes. Remember, in any optical communication system, uh, optical communication system can be established by uh, having optical fiber as medium and transmitter and receiver. So in the transmitter side, there is optical sources, and in the receiver side, there are optical detectors. You are all know this. And in the optical source side, you may have LED or you may have lasers. So the main function of these optical sources are they will simply convert whatever the input that is we are giving, maybe audio, video, or any electrical systems, any input, they are simply converts into light signals or photons, into radiation. Simply you can say into radiations. So the optical sources simply converts the input applied into radiations, optical radiations, also called photons. So this is the main functionality. You know how the LED basic principle, how it is constructed, all this last class we discussed. Today we will see laser diodes or laser. What is a laser? Laser is an acronym, like amplification by stimulated emission of radiation. So the laser output is also again radiation, again light. But there is a difference between LED and laser. So, in the LED, the simple process happening. What is the simple process? Recombination. Recombining electrons and holes when you apply forward wire. But in this laser diodes, in the laser diode, there are three processes happening. There are three processes happening. In this laser process, the first process is absorption. Absorption. Second one is spontaneous emission. Next one is stimulated emission. So we require from the laser process, in this process, ultimately we are requiring a stimulated emission. Why we don't want spontaneous? Why we don't want spontaneous? If you expect spontaneous, the radiations are very light. The intensity is very light. Very light, less intensity you are expecting when you treat as spontaneous emission. But if you expect stimulation emission, you may expect high radiations. That is the main cause for expecting stimulated emission from the laser diodes. Fine, but the question is, how do you expect a stimulated emission from the laser? You are all known that in the first year BTECH level, you are studied engineering physics, right? There you may studied about laser diode, structures, all these. Once again, I will recall the same laser principle. Listen carefully, right? So you know the quantum process. You know the quantum process. The quantum process means take any material, the material composed of atoms or molecules, right? Atoms or molecules. So what is atom? Atom having some number of energy states, number of equal energy states. If the atoms are equal in the material, if the atom or molecules are equal in the material, the energy states, the atom having number of energy states, like energy state 1, energy state 2, like this. Number of energy states within the atom. Okay, fine. And there is a possibility, there is one possibility. Suppose if any material exposed to any radiations, exposed to some energy, external energy, what happens? If a material exposed to any external energy, the atoms within the material may move from one energy state to other energy state. Listen carefully once again. If a material exposed to external energy or any photon energy, say what happens? The atoms within the material may take a transition from low energy states to high energy states. Generally, generally they are going to jump from low to high. Low to high. This is called jumping process. Jumping process. This is what happening in the material. And the important thing is, once the atoms may take a transition from low energy state to high energy state, the atom cannot be stable at the high energy state. They will always come down to low energy state because the high energy state cannot be stable. So the atom cannot be take any external factor, external energy in order to jump from high energy state to low energy states. It cannot take any energy, any external energy. Simply it jump from high to low again. That is called spontaneous. What is absorption? Absorption means for a material, if you expose any radiation, if you apply any external energy, the energy is absorbed by the material, so that the atoms within the material may jump from low to high. That is called absorption process. Absorption process. And what is spontaneous? Spontaneous means when the atom is within the higher level state, it by taking no external energy, the atom may comes down from high to low energy state. This is called spontaneous. What happens in the spontaneous emission? When the atom may jump from high to low, it releases some photon, some photon, some light it releases. That is called spontaneous emission. Spontaneous emission. Remember, from the laser, we are not expecting spontaneous emission because whatever the whatever the atom emits some photon, when it comes down from high to low, it is less intensity. It is very less intensity. So very less radiation we are expecting from any material. It cannot be visible. Hello, it cannot be visible. It cannot be. That's what that cannot be useful for our optical communication purpose. So we need useful radiation from the laser. So what can you do in order to get useful radiation? Useful radiation is what? High radiations you want. When the atom may jump from high to low energy state, we expecting high radiation, high intensities, monochromatic light, high direction, high sensitivity light, directionality. We want more directionality light. How it is possible? It is possible by making some modifications for the material. The modification nothing but the question is, the point is, if any atoms are in the high energy level state, it will come down so that radiations will release. Fine. But my point is, if more number of atoms are there in the high energy state, if more number of atoms are available in the high energy state, they will jump automatically toward, they will jump, once they jump from high to low, we can get maximum radiation. Yes, sir? Maximum radiation. But the point is, how do you how do you create more number of atoms in the high energy state compared to low, compared to low, compared to low energy state? It is a process of population inversion. Population inversion. So you have to create a population inversion in the material. So in order to create a population inversion in the material, we need a pumping process. We need a pumping process. What is a pumping process? Pumping process is nothing but creation of more atoms in the high energy state. High energy state. If more number of atoms are available in the high energy state, like E2, they will come down towards E1 so that some H nu, some photons are released, which is nothing but radiation, which is having high intensity. So you have to create a population inversion with the process of pumping process. Pumping process. Right. So this is the background of uh, your quantum process. And one more point here, the atoms which are available in the high energy state, because they are unable to stay at the high energy state, they will always towards come down. They will always towards come down. Okay, but the point is, some atoms may come down from high energy states to low energy states. Maximum atoms, they require external energy. Maximum atoms which are available in the high energy state, they need some additional energy towards in order to comes from making a transition from high energy state E2 to low energy state E1. But who can provide that external energy? We have to provide. For a material, we want to provide some external energy again, so that by taking that external energy, the atoms in the high energy state may push, the energy will push the atoms in the high energy state towards down E1, so that we are expecting high energy, high H nu as output, which is nothing but required radiation from the laser, which can be treated as stimulated emission. What is stimulation? Stimulation means external energy we are applied for the atoms which are available in the high energy state. High energy state. So we always expecting stimulated emission, which will be useful for high intensity radiation for optical communication purpose. Optical communication purpose. Not only optical communication purpose, for our purpose, for our medical instrumentation, for our industrial instrumentation, or anywhere. If you want to measure anything, any unknown parameters in the industries, medical side, diagnostic side, we need high radiations from the laser. High radiation from the laser. How do you get high radiations? Because of stimulated emission. Stimulated emission. So, absorption, number one. Number two, spontaneous. Number two, stimulated emission. Stimulated emission. Okay. Why we need to prefer generally in any optical communication for optical communication side, lasers are very important light sources because of some characteristics. Some characteristics. Laser having more advantages than LED, because if you use LED and you provide any fiber cable, LED is this side and fiber is this side. If you couple the light source to the LED, coupled to the fiber, what happens? When the LED lights emits, the total light which is emitted by the LED may not be coupled to the fiber, because of LED having more surface area. more active region, I mean, active area is large size. So whatever the light is emitted from the LED, the total light may not be coupled to the fiber, may not be coupled and entered to the core of the fiber. So what happens? Maximum some of the light emitted by the LED may be wasted while coupling LED with optical fiber. But he come across with the laser having more directionality. So less surface area, less active region. So from that we are expecting laser light which can be easily coupled to the core of the fiber. Core of the fiber. See, we can reduce wastage of light in the laser fiber alignment, and we can waste maximum most of the light when we couple LED with fiber. Understand my point? Understand? So the laser importance is like this. For this communication, I don't want to speak about LEDs waste. I'm not speaking LEDs waste. LEDs having some disadvantage. I'm exposing this word compared to laser. So laser is more directionality, more intensity, more intensity compared to LED. So this is about laser diode. And go to the next slide. Next slide. Yeah, yeah. You take, you know that all these optical communication system link. The optical fiber communication system link comprises like the optical sources, I mean transmitter and receiver in between a medium optical fiber, right? Okay, we are discuss about source and sources available in the transmitter, LED and laser, and you know about fiber, optical fiber, and come to the last end of the fiber. The end of the fiber nothing but optical receiver, optical receiver. What is there in the receiver? Generally, in the receiver, having very important device or instruments, nothing but optical detectors. Optical detectors. In the syllabus, you have two optical detectors. Very important two optical detectors. So we have number of optical detectors like PIN diode, avalanche photodiode, photo transistors, photo multipliers, photoconductors, like this. There are number of optical detectors are available, but as per the syllabus, we have only two optical detectors or light detectors. They are nothing but PIN detector and avalanche photodetector. Number one, PIN detector. Number two, avalanche photodetector. These two detectors are available in the receiver side of as per your syllabus. Receiver side of your optical fiber communication or fiber optics or laser instrumentation. Fine. But what is the main function of these optical detectors or light detectors or light converters or light converters? Why I am using the word light converters or photon converters? So light converters, photon converters, or light detector or photodetectors, all are same. The main function is when the light emits from fiber end, at the end of the fiber light emits, the light will fall on the photodetector, the light will fall on the photodetector, the photodetector simply absorbs the light and converts into electrical signal. Converts into electrical signal. So this is the main function of your detector, photodetector. The photodetector simply converts the light signal or photon into corresponding electrical signal. Corresponding electrical signal. We come to the case of light source. Light source like LED or laser simply converts the whatever the input into light signal. I mean electrical into light. But projector converts light into electrical, light signal into electrical. These are the difference between light sources and light detectors. Fine. But we have two light detectors, PIN diode and avalanche photodetector. But what is the structure of a PIN diode? Go to the next slide. Is there available PIN diode? Amma? Yeah, fine, available. Okay, see that PIN diode. How do you form? How do you construct the PIN diode? PIN diode is simply constructed with the help of simple PN junction. Simple PN junction. Hello, you know PN junction? Consider P layer and N layer by doping with some suitable impurities in the process of doping process. See here, this P plus, see the structure? P plus refers to heavily doped P. N plus refers to heavily doped N region. So in between P and N, very lightly doped, very lightly doped I region. I refers to intrinsic region. So heavily doped P, heavily doped N, and I nothing but intrinsic region. Intrinsic means pure. It is called pure. Pure N region. Remember, hello. Pure N. Lightly doped N region. It looks like intrinsic. Intrinsic. This is the structure of PIN diode. PIN diode. PIN diode means P plus I N plus. This is the structure of PIN diode. For a PIN diode, if you apply a reverse bias, remember, my dears, for LED, you are applying a forward bias. If you apply forward bias, recombination takes place in the LED. Holes and electrons are recombined each other, recombines each other. The LED emits some radiation in the form of heat. Or if LED is very good compositions, you may get after recombination, it emits radiation in the form of light. That's what happens in the case of LED. So my point is, for LED, it works on forward bias. But PIN diode, it works on reverse bias. Keep it in mind. The PIN diode works on reverse bias. If you apply reverse bias, what happens? Reverse bias means battery P is given to battery positive terminal given to N plus ohmic contact, and battery N is given to P plus region through ohmic contact. Ohmic contact means connection. So apply reverse bias to the PIN diode. So when you apply reverse bias, what happens? You know, in the when you are studying some atomic structure, all these in the engineering physics or in the EDC subject, basic electronics, what happens? Tell me. The electrons which are majority carriers in the N region, N plus region, may attract towards P terminal, battery P terminal, and the holes which are majority carriers in the P region, P plus region, may attract towards battery N side, battery negative side. So what happens? It widens the intrinsic region. This potential barrier is extended. Yes or no? The potential barrier is extended. Fine. So because of extended intrinsic surface in the PIN diode, when the light is incidented, when the light is incidented by the end of the fiber, because at the end of the fiber light is emitted. So when the light will fall on the eye region of the pin diode, the total light is absorbed. The total light is absorbed by eye region, intrinsic region. When the light is absorbed in the eye region, it creates photocarriers. The surface eye region will create the photocarriers. Photocarriers means what? When the light is absorbed by the material, due to material characteristics, the material surface having some photocarriers, maybe electrons. Strictly speaking, here because of lightly doped end region, it creates electrons. I am not speaking that no holes are available. Maybe some holes are available. We can speak photocarriers in the sense, photocarriers means holes as well as majority electrons. Holes as well as majority electrons. I can say in one word, hole electron pairs are created in the eye region. In the eye region. Understand my point? When the light is emitted on the eye region, the light is absorbed by the material. When the material absorbs the light, it creates whole electron pairs. Whole electron pairs. And when the whole electron pairs are created, because of reverse bias, the carriers may take a transition. Because of reverse bias, across this reverse bias junction, isn't it? The carriers, the photocarriers are whole electron pairs. Some may be recombined, but some may not be recombined. So whatever the not recombined whole electron pairs, they may take movement. They may take movement because of mobility. Because of mobility of electrons and mobility of holes within the intrinsic region, they may take transition. They may take transition. So when they are making some transition, you tell me mobility of electrons is high or mobility of electrons is high or mobility of holes is high. Generally, mobility of electrons is high. So movement of electrons, because of the reverse bias, what happens? It creates a photocurrent. What is current? What is current? Current is what? Moment of the carriers. Moment of the carriers. So here dominated electrons within the region I, because of mobility is high for the electron, they may take high moment, high mobility, it creates photocurrent. It creates photocurrent, right? So what happens when the light falls on this? The region, the pin diode simply converts into light, converts into photocurrent. Current means here electrical signal. If you want to see electrical signal, just simply connect a resistor, bypass a resistor. Through the resistor, you connect a meter in series. You may get some how much current you're expecting because of a photon conversion or light conversion by the pin diode. You can see in terms of nano milliamps or milliammeter. You can get some current because of that light. So the pin diode simply converts the light signals into electrical signals in the form of current. Or if you want voltage, you connect a voltmeter across a voltmeter, across a resistor, you may get nanovolts or millivolts. That is your wish. That is, we are going to process again. We can process again, converting into current or current to voltage. That is in our hand. But the basic thing is the pin diode simply converts light signals into electrical signals. This was the process happening in this structure. Go to the next slide. Next slide. Next slide. Yeah, very good. Yeah, it is looks like it is look another other please all of you okay, this is other photo, other optical detector as per your syllabus is APD, avalanche photo detector. Avalanche photo detector. Avalanche photo detector structure is like this. So, what is the structure of pin diode? P plus N plus I. P plus N plus I. But avalanche photo diode nothing but a modification of pin diode. APD nothing but modification of the pin diode. How do you modify? Into the same structure, you just add a P additional layer. P additional layer. See the diagram. See the diagram. P plus is same, M plus is same, I is same. But what is difference between P and APD? Only P region. Only P region. No, 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 no. Go to the slide. Yeah, zoom it. Okay, so these are basic difference between P plus N plus I. Just we are adding a P additional layer to the structure. To the structure. The same pin diode structure. For this, we are adding additional P layer, which gives us a APD, avalanche photo detector. It is nothing but one more photo detector which converts light into electrical signal. How it converts? As I explained just now. Just now. See, it is a P layer, P plus layer, N plus layer. It is exerted by a large reverse bias. Remember, very large reverse bias. We are applying for the APD. As a, whatever happening in the pin diode, the same operation is going to happen in the APD also. But one difference. One difference. What is difference? We are adding P layer. P layer. Yes or no? P layer. See, P layer followed by N layer. P layer followed by N plus layer. It is also one more PN junction. We applied large reverse bias. So, between P N plus junction, it creates at this junction, there exists large reverse bias also. Remember, large reverse bias. Because of additional P layer, in conjunction with N plus layer, it creates other PN junction. It creates other PN junction which is already excited by large reverse bias. Large reverse bias. So at this junction between P and N plus, there exists large reverse bias. Remember, this is the point. Then, when the light is incidented on the I region through P plus, when the light is incidented between on the I region between P plus, the light is absorbed in the I region, no doubt. Light is absorbed in the I region. So when the light is absorbed, what happens? As we discussed just now about pin diode, the material, the surface will absorb the complete photon. Complete light is absorbed by the material. What happens? The surface will give you photo carriers. Photo carriers means electrons and holes. Photo carriers. Because of mobility, the carriers move towards P and towards P and towards N plus by crossing additional reverse bias junction. The photo carriers, whatever generated in the region, they may take Saujanya, Kavya. Sorry for the disturbance. Before the class, all of you should mute your mobiles, otherwise we have a lot of difference. Okay? See, the photo carrier simply accelerated through P and by crossing additional PN junction towards N plus. So what happens when the photo carriers may take movement towards P and through N plus through by crossing additional PN junction because of large reverse bias. Large reverse bias, it will accelerate. They may accelerate. It creates high acceleration, and because of high reverse bias, what are the photo carriers generated in the I region? They are multiplied. The photo carriers are multiplied. Photo carriers are multiplied. That they are collide with other carriers. Again, they are multiplied. So, like this, what happens? The multiplication of the photo carriers takes place because of high reverse bias uh, electric field. Because of high reverse bias electric field, electron multiplication takes place. It is nothing but avalanche avalanche effect. It is nothing but avalanche effect. What is avalanche effect? When the photo carriers are generated because of high electric field, high reverse bias electric field, the electrons are collide with other photo carriers and they are generating more and more electrons, more and more photo carriers. So because of electron multiplication, we can get maximum photo carriers, and because of maximum photo carriers, you may get maximum photo current, and because of maximum photo current, you may get maximum current, maximum electrical signal from the APD. But it is not happening in the PIN diode. PIN diode doesn't have this structure. You may get less current from the less conversion, light into electrical signal. But we can get maximum current from the APD because of electron multiplication. It is also called reach-through effect. Reach-through, because the electrons which are multiplied, they are reaching towards additional reverse bias junction. This is called reach-through effect or avalanche effect. Because of reach-through effect, we can convert the whatever the light into suitable electrical current by the avalanche photodetector. Like this, as per syllabus, we have only PIN and APD. Right? This is about your photo detector. And tomorrow we'll see remaining remaining topics. And don't worry, whatever the class we are discussing, I will give you in the by creating a YouTube channel, or I will give the YouTube link for this accessing this. You are giving some mails for requesting me through Google Drive. Don't bother, I will provide the YouTube link, right? So thank you. We'll meet by tomorrow. If you have any doubts, please come forward.